Here we're going to run through the solutions to the other problems on the section 2.4 worksheet. So we go through our process in each case here, and the process starts off by finding the critical values. So to find critical values, I need to take the derivative of our function. So we have 3x squared minus 6x, and I'm going to set that equal to 0. Well, maybe, let's see. So 3x squared minus 6x equals 0 will mean that 3x times x minus 2 equals 0, which means that x is 0 or x is 2. So those are critical values. I only keep ones that are in the interval that I'm interested in. In this case, the problem always comes with a function and an interval. And we see that both 0 and 2 are in the interval. So I'm going to keep all of these numbers. So my values of x are, that I need to consider, are 0 and 2 for the critical values, and -1 and 4 for the endpoints of the interval. So this is all the places where I might possibly have an absolute max or an absolute min. And so rather than do a bunch of shape analysis of the graph, I'm just simply going to compute the y-coordinates for each point and then answer with whichever one is biggest or smallest. So these are all pretty easy to put back in. Realize when you're trying to find y-coordinates, you're talking about the original function again. So f of 0 is 6. F of 2 will have 8 minus 12 is -4 plus 6 is 2. F of -1 will have -1 minus 3. -1 minus 3 is -4 plus 6 is 2. And f of 4 is 4 cubed is 64, minus 48 is 16, plus 6 is 22. So I have the largest possible y-coordinate is here. It's the largest of all of these, so that's the largest y-coordinate. So that's my absolute maximum. And I've circled both the x and the y-coordinate. That's a point, 4, 22. And I have a tie for the lowest point, but that just means that it can occur more than one place. The absolute minimum is absolute minimum value is 2, and it occurs twice. It occurs once when the x-coordinate is 2 and once when the x-coordinate is minus 2. All right, so in the second problem, I do the same thing. Here's my derivative. I'll have 8x cubed minus 24x. Once again, when I set that equal to 0, I'll be able to factor something out, so I'll factor out an 8x, and I'll have x squared minus 3 equals 0, which means that either x is 0, or x is the square root of 3, or x is negative square root of 3. Now, I'm only interested in those values that are on this interval. Certainly 0 is between minus 2 and 1. Square root of 3 is about 1.7, so it is not, square root of 3 is not in this interval. Square root of 3 is bigger than 1. Negative square root of 3, on the other hand, is in this interval. It's about negative 1.7. So I get rid of this guy. It's not, something might happen there, but I don't care. I'm only interested in what the picture looks like between minus 2 and 1. So again, I have now some x values. So x could be 0. X could be negative square root of 3, or x could be negative 2, or x could be 1. Those last 2 points, again, are coming from the endpoints of my interval. And for each one of those, I'm going to calculate the y-coordinate. So when x is 0, y is 5. Remember, I'm putting this back into this formula to get my y-coordinate. When x is the negative square root of 3, then here I'll have 2 times 9 is 18. 18 minus 12 times 3 is minus 36. So 18 minus 36 is negative 18, plus 5 is negative 13. So you might double check me on that, but I think it's negative 13. But I'm trying to put in negative square root of 3 in for x here. And then when I put negative 2 in for x, I'll have 2 times 16, so that's 32, minus 12 times 4, so 32 minus 48 is negative 12, plus 5 is negative 7. And finally, when I put 1 in, that's easy. 2 minus 12 is negative 10, plus 5 is negative 5. So of these values, there's only one that's even positive, so this is my absolute max. That's the biggest y-coordinate that I see. And the smallest y-coordinate that I see is here with a y-coordinate of negative 13. So that must be my absolute minimum. Okay, and the last question, I have taken the derivative of this guy several times before, so I'll just write down what I get. I know that the derivative here is 7 times 25 minus x squared over x squared plus 25 squared. And I know that's because I've just done it before. We keep using the same problem. But it's the quotient rule, and the numerator is simplified. And so this is equal to 0. I don't even bother writing it again. When x is plus or minus 5, but neither positive 5 nor negative 5 is in this interval, and so there are no critical values of this function that are actually between 1 and 4. So when I go to check my xy pairs, I really am only checking the two endpoints. There's no critical value that needs to be considered. When I put 1 in for x, I will get 7 over 26. And when I put 4 in for x, I'll get 28 over 16 plus 25 is 41, so 28 over 41. So this is the bigger number. So this is the bigger number, so that is my absolute max. And smaller number here is my absolute min. So I would say that my maximum value of the function is 28 over 41, and it occurs when x is 4. My minimum value of the function is 7 over 26, and it occurs when x equals 1. So you'll hear that kind of language used in this section.